Welcome to the Foundation for Water Research and Chartered Institute of Water Environmental Management Wastewater and Biosolids Panel meeting presentations that were given on the 24th of June 2020. We had presentations from Dr. Mehdi Khoury of the University of Exeter on serious gaming, Professor Dragan Savic from KWR on sewers for COVID and tracking pandemic through the wastewater system, and also from Karen Georges of our utilities on using WhatsApp as an international collaboration tool for the COVID-19 crisis. So our first speaker was Dr. Mehdi Khoury of the University of Exeter, and he was talking about the very interesting concept of using serious gaming in the water industry for collaborating with customers and people within the industry.
Today our first presentation is by Mehdi Khoury of the University of Exeter, who's going to talk to us about serious games.
All right.
On you go, Mehdi.
Thank you, everybody, for coming and attending. So, yeah, that's kind of a bit unusual. You would think, what does gaming have anything to do with, the water sector or industry and all these things? Well, serious gaming is a bit of a strange animal. A serious game is some sort of gaming application or some application, but which is developed for a purpose which is other than just entertainment. So you could use very complex games or make very complex game or fairly simple one, but with different goals in mind. They're just, making people happy and entertained. Things like raise awareness, facilitate dialogue, which is all right, which is the low-hanging fruit. But then you can also use this kind of software that you develop to make people learn skills, how to work as a team, how to optimize a team process with some sort of complex optimization problem in which people would have to make compromise. Or you could also, on top of the game, put a simulation engine and make people discover about the behavior of something. So overall, developing serious game, you could use it for all sorts of purposes. But I'm gonna give you the example of Millbrook. The slides that you see there are links which are live. So if you want to get to the game, you directly go to the website. You'll be able to download the game and run it if you've got a Windows machine. And there's also a link to the paper. So let me demonstrate the game. Basically, that's roughly the end of my slide, because there's no point talking about software without being able to demonstrate it. Let's just show you what's happening. So the village of Millbrook in Cornwall has known some flooding, repeated flooding actually, and this game has been developed because of what was happening in Millbrook. You can see the village in the background. So let me give you a little bit of context. One evening, I was asked to come to Millbrook, and after a fairly long drive in the British countryside, I must say, it was a fairly rainy afternoon. We were induced into the scout hut of the village. This is actually a little miniature version of the village of Millbrook that you can see in the game itself. There's all sorts of documents about the history of the village and the flooding problems and all that. So what has happened is several times in the past, Millbrook has been flooded, and when it floods, after something like 1.92 hours, this is what happens to the center of the village. And it happened to them several times in the past few years. So when you see a building in red, that means that you got more than 50 centimeters inside the house. When it's in orange, there's between 30 and 50 centimeters inside. And you can imagine that, some of these buildings there, this is the pharmacy of the village, they're like commercial things, there's like residences, so this is catastrophic for such a small place. So when we came to this meeting between the Southwest River Trust and also the water company, sewers, the people in charge of the sewers, and the village residents, there was a lot of hostility going on, because it had been not just the first, but the second or third time the resident had been flooded, and they were blaming the utility company for their flooding. They said at the meeting, well, you know, we've got this reservoir here. We think that when it's raining, the reservoir overflows and floods the village, which is actually not what was happening. The resident had been given a report saying that the level in the reservoir was lower than the level of water in the village, and in fact the reservoir was saving the village from worse flooding. But this was a strange case in which, when you came to this place, it was very tense in a British way. People stayed unshakably polite, drinking tea, but they had in their mind it was definitely the service company fault. They thought it was because the pipes under the village, the sewer pipes, were not big enough. The situation in the village of Millbrook is that, I'm going to zoom out a little bit. If you look at the overall of Millbrook and you zoom on the fields, you'll notice that these fields are cultivated with cows. You can see the passage of the cows. You can see the eroded grass with this compacted mud. And there's also maize. So what's happening is, with this kind of cultivation, when it's raining, the water slushes straight through the bottom of the village, and is not really being absorbed by the ground. So that's the real cause of the problem. And when we went to this workshop, people didn't want to accept that as the cause. So that's why we developed this serious game, in the hope that perhaps, you know, we would change the standard workshop and change the outcome and get some positive feedback. So we developed this game, and I'm going to show you a little bit more. So what happens is, the game on its own is not enough. You need to give people context. So what we did is we gave people some sort of introduction about the problem of Millbrook, you know, general setting, and then we asked the players, some of the residents from Millbrook, to answer some questions, more specifically to reject or to confirm some hypotheses about the Millbrook flooding problem. Typically, for example, we asked them, before playing the game, do you think that improving the village sewer infrastructure could neutralize most of the flood? And if you don't really know that much about the problem, you might think yes, right? So we make them then play the game, in which they can explore all sorts of consequences and see the results. And then afterward, we give them the same questionnaire, and we see if there is a difference induced in the way they answer. And the way it worked is, it worked really, really well. We had a significant difference in the way people answered the questionnaire after playing the game. So to get back to the game itself, you've got this little interface with a miniature village, and what you can see there is after 2 hours of raining, you can see the number of flooded households, the amount of damage for the buildings, but also the cost of the present sewers infrastructure, and also farming profitability. So what's happening is, we divided the catchment into 3 areas, because there is actually 3 farms that own most of the grounds, the fields around Millbrook, and we divided this catchment into 3 regions in which we can drag and drop different types of farming systems. And what's being used at the moment in Millbrook is heavily grazed permanent pastures and mixed with intensive arables. So this is roughly what's happening. Here we have the level of infrastructure. We have set up the system so we could choose between a low-cost infrastructure and a high-cost infrastructure. And what happens is, if we switch between the low and the high cost, we'll see if there's a change to the flood print. So I click on high, it's going to calculate something, And then we'll see that there's actually no difference. I get back to low-cost infrastructure, small pipes, okay, big pipes, no difference. It's exactly, roughly the same amount of flooding and damages. But the cost is instead of 200,000, it's a 400,000 cost. So we've doubled our cost to try to increase the amount of water infiltration that the system can allow us, but now it doesn't really improve anything. On the other side, if we start dragging and dropping different farming systems, particularly no-tile systems, like you know, things in which there is no, you don't till the earth, you just pierce little holes, and you let a little vegetation cover of beans and things like that on the surface of your crop as well. Then if you start dragging and dropping this kind of farming system on different portions of the catchment, you will see the flood print changing considerably. So I'm dragging this deep green, which is this no-tile system, and you would see suddenly the flooding is mostly neutralized. So, and the farming profitability has actually gone up. So this is interesting. Most people, before they see the problem, most of the participants that played the game were thinking that, you know, farming profitability can only maintain with, very intensive farming, either cattle or things like maize. But actually, no, you can get more profitable types of farming system. And most interestingly, you can completely neutralize the flood in the area just by changing the farming system. So what happened is the residents of Millbrook, actually, ironically, only 2 people from Millbrook came to play the game, but one of those was the accountant of the parish. And the lesson I got, ladies and gentlemen, from that was if you want to change things in a parish, always invite the accountant, because after playing the game and seeing that you could neutralize most of the flood just by changing the farming system, they literally went back to the parish in their council meetings, and they changed their investment priorities. Instead of trying to put a lot more money into bigger tubes under the village, they started to try to help the farmers to change the way they were cultivating around Millbrook and to do some more nature-based management answer to the problem. So to give you a little appreciation of what was going on for the participant, I'm going to show you typically the kind of response we had. So remember, there were questionnaires. So what we do when we make a serious game like that is we measure how people answer the questionnaire before playing the game and how they answer the same questionnaire after. And if we can measure there is a significant difference, statistically significant difference induced by playing the game, then we won. That means that playing the game really changed people's understanding of the problem. So typically, to give you an example, when we got a question like this one, do you think improving the village sewers infrastructure, drain excess water, could neutralize most of the flood problem? So at first, in the yellow zone, this is what most people answered. Most people were like between agree and disagree and neutral. So you can see the number of people on this scale in the yellow blob is the pre-questionnaire result. So most people were undecided. There some would agree, some would disagree, and nobody was too sure. But the red area is what people answered to the question after playing the game, and you can see there's a strong change, a strong shift toward a strongly disagree and disagree. So that means they really think that making bigger sewer pipes under the village would actually not be the solution to the problem. So in a way, this is one of these strangely easy success stories in the sense that we made two people play a game. It actually made the whole village change their strategy on how to cope with flooding in the sense of investment policy. So this is one of these rare cases for serious games, because I don't know many cases of games which have made that. But to put things into perspective, you know, you could reuse that kind of principle, that kind of game design for lots of other areas in which similar mechanics can help, about the way you farm the land, but also on other things, like, for example, in town, if you build lots of area with concrete, you might completely change the flooding consequences, and that's something you could integrate in such games. Similarly, you can, if you want, not just stop there, and instead of just sending customers as a water service company, if we just send customers questionnaires about, you know, how they want to see their water service go, they might not always get particularly involved nor interested. But if you start giving them sort of mini serious game things in which you give them a budget and what priorities should the service operator see, what should they invest in from their point of view, then people might actually, by looking at the different parameters of this game or this system, find that the most optimal solution would be lying in this kind of measures or this kind of costs. And that's one way to reach customers and communicate with them and to make them more sensible, in the sense that to make them more open to the kind of constraint you have. And this is kind of an interesting thing in the context we have now because of global warming and the fact that resources are more scarce. Water is not as cheap as plentiful as it might have been in the past. And the regulator is starting to find water operators, people like Thames Water and others, and they're getting quite nervous about the fact that we don't try to communicate enough with the customers or people. And if you want, that's one more technology, one more tool that you can add to your arsenal to not just communicate with people, but also make them see the most rational solution to a problem, which is, you know, something which is fairly useful. On top of it, it's a kind of tool, call it a game or not. You can call it a decision support system or a simulation tool. But it's a game you can use to train people like technicians or engineers as teams as well. So if you've got some objectives that you need to optimize, and when you've got a sandbox in the background, and when one of them does change something or tweak a parameter in the system, the other colleagues' output would be changed, and then they need to get back to the drawing table and talk about it and find some sort of compromise as a team. So I think I'm gonna stop there. I've got a few minutes for eventual questions, but it's just to give you the general context. That technology is mature, it's easy to do, it's fairly cheap. Nowadays, to make a multiplayer game online from a web browser is just a matter of weeks, literally. And you don't need a team of software engineers. You probably need one person to know what he's doing, but that's pretty much it. So the whole avenue of possibilities is just opening with this kind of tool. So I will finish there. And if you've got any questions, I'm quite happy to answer.
So thank you, Mehdi. It kind of opens the floor to see if anyone's got any questions on it.
I've got a question, Mehdi.
Sure.
Thanks for the presentation. That was great. You were saying, I'm just trying to get a little more detail on the change in the farming practice, because that was really interesting.
Yeah.
You were showing that the farming profitability went up. Was that because the yield increased, or was that because there was some other value adjustment that came in, like a subsidy for set aside or something?
Now, that's a good question. what I did is I went to the standard official farming profitability figures website per types of crop. And I didn't analyze the real cause of why some stuff was more profitable than others. Although there were some biggies, like things like, if you've got intensive cattle or some types of crops are heavily subsidized, but that doesn't make them particularly profitable as a general thing. So there were several factors. The profitability is something I just used some figures which were from some specialized statistical websites. And you could discuss that could vary quite a lot from one farm to another, depending on the practice. It's very difficult, right? I mean, the model is an approximation. But overall, you had a surprising amount of better or slightly better profitability from non-conventional farming methods, things which were not centered on heavily grazed permanent pasture and intensive arable with tillage and standard rotation. We took into account other things, right? I mean, about the erosion, the flooding, and water infiltration rate, how some crops, some types of crops could change the water infiltration rate, the terrain roughness, and also sediments caused by this type of cultivation could block the drainage. But yeah, to answer your question, it's a so-so. We got some surprising figures out of that website, but it doesn't mean it's always working. You see what I mean? It was just more like a generality.
Yeah. No, that's interesting because there's a question that occurs to me, which is how far can you extend it, depending on the overall profile of current profit coming from different agricultural operations. And there is a lot of subsidy in agriculture anyway, so it's very difficult to disentangle. And I guess one thing that could occur for the future is that you just change some of the subsidies. So rather than subsidizing intensive agriculture, there's a subsidy in there for minimizing impact on the urban area, minimizing the flood risk.
That would be one way to do it. And I think when you consider the small amount of help involved to local farmers compared to the gigantic amount involved to redoing the sewers, it's probably a lot more sensible to try to help the farmers to change their farming system from a financial point of view.
The other thing that occurs to me from what you were looking at there is that I was sort of mentioning biodiversity earlier. Moving towards some of those tillage systems, a no-till system is going to increase biodiversity as well. So that there are other things in there that currently there's no cost-benefit registered with yet, but there are benefits in there that do have a value.
Yeah. Note that one factor that comes in for this particular flood, the water infiltration rate problem, is also the nature of the soil, right? I mean, here we were on a sandy soil, quite acidic near the sea, and it was not the best soil. To be honest, it was a fairly bad one to do this kind of experiment, but the soil specialists that did it still noticed that from a water infiltration rate, instead of having 10 millimeter per hour, we could get up to 90 millimeter per hour, and it was very conservative. That means we got actually better results than that, but we just decided, well, let's calm down. Let's just put it at 90, just 9 times better. But the truth is, if you got a better type of soil, like toward the land, inside the land, a little bit less than sandy soil, then you get actually microporous holes in the ground that are formed by having this, this mixed rotation on top of the cultures, and you get an even better result that goes easily up to 200 millimeters per hour.
Wow. Thanks for that. It's really interesting.
Thank you, Mehdi. We've got time for a quick question from Barry, and then we'll move on to Dragan's presentation.
Okay, well, I'm trying to be quick. I work for the Environment Agency. We have lots of contentious issues with communities to deal with, and I can see lots of potential opportunities for using this sort of approach. Are there other examples that you're aware of where gaming has been used like this? And my second question is, why in a situation where people are not trusting the sort of authorities, why did they believe the model? Was there any challenge to what the model was saying?
Well, everybody, of course. I mean, there's not a magic tool. If somebody doesn't want to change their mind, they're not going to change it, right? I mean, some people are determined to not accept something and there's nothing you can do about it. But there is one particular thing about the design of the game. It's a bit like well, I'm going to go back in history there. It's a bit like a Socratic method. So what you do is you give people hypotheses to confirm or reject, so they've got in mind the answer to the question that they think is right, okay? Then you make them play the game and you make them explore all the different sets of solutions and parameters, and afterwards, when they have experimented with it, then they realize, oh, wait a minute, that type of farming doesn't work at all. It does make the flood a lot worse. And in fact, the infrastructure investment doesn't help anyway. So I'm better off just changing that. And once I've put this no-till system, then that's a solution to my problem. Yes, you can. People always question models, but when you say that the models have been built using quite a lot of science behind it, there was several scientists from different areas involved in doing that, hydraulics and soil and all that. The person which was in charge of the account of the parish was probably the most convinced. But overall, from all the participants we registered a shift of opinion which was superior to the shift you would get by making people trying to read an 80-page long report.
Yeah, sure. I can see that. Thank you.
I don't know if you've read, I'm sure you're aware of the Kahneman book, Thinking Fast and Slow, that talks about the work he and Tversky did about type 1 and type 2 thinking, and the fact that most people, it was a study on human psychology, and we talked about how people can make instinct-based decisions as opposed to actually reasoning their way through things. And this fascinates me because what it says to me is that you can see that a lot of people will fall back on type 1 thinking, where they just make an instinct-based decision. But if you're giving them a model, an accurate model of something that's going on, it will challenge their opinions, it will challenge their instinct-based thinking and their intuitive thinking. And where the intuitive thinking goes wrong, it gives them evidence in front of them to actually basically push back on that opinion.
That's the positive outcome we actually got. It's the fact that people by themselves, when they were given the tools to do so, decided that their previous opinion, their preconception on the problem was actually wrong, and we got a lot of significant change in their way, in their perception of the problem. Yeah.
Our next speaker was Professor Dragan Savic, who is the CEO of KWR and visiting professor at the University of Exeter. And Dragan was talking about SIRS for COVID and how it can be used to track the pandemic through the SIRS system with results up to 6 days in advance, which obviously would have a great impact on preparedness in dealing with the crisis.
Thank you, everybody, for the opportunity for me to speak today. Talking from my spare bedroom in the house. Basically, Oliver asked me to do something about rapid prototyping and what we've done recently for a competition, Sewers for COVID. Sewers for COVID was consortium that was looking into digital health observatory using sewer surveillance, basically testing sewer wastewater just before large wastewater treatment works, whether we can detect, in this case, SARS-CoV-2 or indications of COVID-19. If you can move to the next slide, please. So what were the challenges? We wanted something that can give an early warning. Oh God, that's not looking good, but okay. Yes, a bit better. Now it's okay. Over 10 years, the organization that I work at, KWR, has been collecting wastewater data and sharing it with the European kind of drugs agency. And now I'm hearing myself feedback.
Can you people?
Yeah. So every year we will collect these samples just before wastewater treatment work, so untreated wastewater, and there are lots of biomarkers, there are lots of transformed substances in wastewater, and the idea is if it's for 1 million people or 500,000 people, you get tested 500,000 people in one go. And we use reasonably fast and very accurate technology using DNA testing, RT-PCR, or it is quite a good one. The lab takes about a day because you have to take 24-hour composite sample, then analyze it, concentrate it, analyze it. And the idea is to link it to the public health information in order to trace or see the progression of the infection. The next slide, please. So we use that idea to develop something fairly quickly for the pan-European hackathon that happened between 24th and 26th of April. The team was from 4 countries: the UK, the Netherlands, Spain, and Greece. And we wanted to look into the whole risk cycle, preparedness for pandemic, early warning system, how to detect hotspots, and then what is the mitigation planning. If you can go further again, please. So as I said, there were 5 organizations from 4 countries. Forward, please. And we only had 48 hours. So if you want a rapid development, you need Mehdi on the team. So you saw the visualization and the game that we've developed that was at Exeter. Now we were developing a new system. We had 48 hours to do it. Next, please. So what did we look for? Where did we look for data? Obviously, sewer surveillance is one of the key data points there. Then we were looking into clinical and epidemic data, what comes from the medical practice or the government in this case. And then we look into socioeconomic data. Obviously, where are the resources for dealing with pandemic? Where are the doctors, nurses, where are the ICU units, and so on. Age profile of people, who are most affected, older people, and so on. And then we looked into other data, for example, social media. If people start talking about somebody being ill, that could have been also taken into account. Next slide, please. So with Mehdi's help, we developed a system that was fully online in 24 hours, a prototype, obviously, and we used the Netherlands as an example because at KWR we had most of the data already collected. So you get a map like this with different municipalities or areas indicating where high concentration of SARS-CoV-2 were found. And then next, please. And we've developed rudimentary artificial intelligence applications for optioneering, for you know, responders. What is the best way to respond to this particular situation? So you know, moving resources, putting more resources in one area, isolating people, and so on. So on the graph on the right, you may see the number of people affected over time. And if you move to the next slide, please, then we would see that our monitoring and intervention would move the graph further in the future. And that's what could help flattening the curve. And that's what the governments are really interested in. So if you go to the next slide. So we were looking into, we developed a scalable platform. Platform is fully in the cloud, if you wish, or on a server, in order to customize it for a particular region, be it a water company region, be it a municipality or a province or part of the country. It will take the order of about 3 months of work. And the idea is you can have a public part of it, which is free for everybody. They can look into the data, see it in this highly visual form, understanding form. And then you can also have a subscription for whatever service you want out of this. So that would be kind of a potential business model. Next slide, please. And this is just to show you what kind of data we had in the Netherlands. We were doing 5 cities. And on the graph on the left, you can see the number, because recognizing the coronavirus in sewers, you need to try and match 4 genes from its RNA. And that's what we're doing with the technology in the lab. So on the left-hand side, as I said, on the y-axis, you have the number of gene copies found in the water, and that's the orange line with the points where we measured. On the horizontal axis, you've got 29th of February until about 20th of May, and you can see the clear coincidence of the peaks both in, and the 2 average lines here, and the dotted dots representing the actual reported number. Blue represent reported cases of COVID in the population as tested by medical professionals, and the gray one is number of hospitalized people due to coronavirus. So you can see the government at this point, the government of Netherlands, the early March stay at home, and then started with intelligent lockdown, and then we have the decrease of these values in sewer, and also you can the decrease in values obviously in people infected. It took time for general population levels to go down, but again, good agreement between those two. The good point is the virus was detected in wastewater 6 days before ever first case reported, in public. Can you go to the next one, please? And this is the latest information. This is very fresh because we have now extended it to June, and you can see that we detected first ones here, and then in the population the numbers came a bit later. And also that there is a bit of a rebound, whether that the rebound is due to more people being tested, but you can see that the same thing happened to the orange line, which is sewer testing. So it is not only due to increased number of tests being implemented in the population. The next slide, please. So that's basically it. That's the idea. We used something that we have already developed for something else, went back, did the analysis, shown that it could be done. Now I think everybody is doing it around the world, and I know that the UK is moving in the same direction. Okay, so I'm happy to answer any questions.
Thank you, Dragan. I believe Steve Palmer's got a question.
Hi, Dragan. Oliver, could you go back to the previous slide, please?
Can you?
Ah, great. The thing that really interests me about what you're seeing in the gene count is that it's giving me more of what I would expect to see as the peak in the population. It's the problem with testing when you're testing in a population. If you're not testing everyone, you may get some attenuation of what's happening with the trends. And it seems you're getting a much more acute signal at the end of the log phase of spread, which is closer to what I'd expect to see.
Yes, I mean, as you say, you get a very good picture of what's happening in the population. You can't do that on an individual. But it's, from my perspective, it's good that we have an agreement with the population kind of testing, individual testing, and I think it's now well accepted around the world. Everybody is trying to do the same thing. They're setting the systems where they can look over time what is happening. How do you decide where to stop the lockdown and ease the pressure on the economy? We've got even a few banks talking to us. They want to do it on a big building, office building. They want to say whether to know whether a large number of people coming back into work are going to be infected or not.
I think what it really interests me, well, this is very interesting on a number of bases, but one of the things that occurs to me is that you're probably able to do what you do far faster and quicker than testing across the whole population on the basis of a RNA test for individuals, the standard test that's out there at the moment.
Yeah,
so,
I mean, even with 2 days required to take the sample, so you need 24-hour composite sample, then you spend the day in the lab because you have to concentrate it and then do the analysis. Analysis takes us about 4 hours, so we're talking about 2 days max.
Right, Barry,
Thanks very much for that, Dragan. It's fascinating. I think this is an incredibly important tool, because one thing in the UK is we're doing nowhere near enough testing. And antibody testing that's been going on has been showing that, generally speaking, there's a level of about 5% in population that have been tested in Europe. And we're seeing nowhere near that being suggested by the actual RNA tests, where people, like in the UK, we're just not testing enough.
Yeah, I think the Welsh government has awarded a contract now for doing the same thing in Wales.
So that might read into what Barry's going to ask a question about. Barry.
Yeah, that was really interesting, and there's a really strong echo, so apologies, but I've been involved in setting this sort of work up in England in a small way, but I was just interested in your view on 24-hour composite samples compared to spot samples, and whether I see that composite samples are going to be better, but do you think that spot samples are also okay to use, or do you think that there's an overriding reason why you should avoid spot samples?
Well, the key reason for that is of the intermittency of, depending on the size of the catchment that is getting the sewers, or number of people connected to the sewers. So if you have larger populations, you will have continuous flows and you will get a much more consistency across different time slots. But I would imagine that the composite sample will give you less variation and give you a more representative sample of the real situation within the population.
Yeah, because what we're trying to do is use composite samples, but in some cases those aren't available, so we're aiming to sample at the peak flow in the morning with a spot sample. And it's going to be interesting to see the differences between those approaches, because I think we're going to potentially look at some dual sampling, composites versus spot as well, to see what the differences are. So
yeah, that's a good idea. Get you a good comparison there.
Yeah. Thank you.
Thank you for the question. Yeah.
Karen, you had a question.
Yeah, I do. So my question is really around, so this is being, countries around the world are replicating what you're doing, and I think it's a really good idea. Do you have a feel for any factors that might influence how successful it might be in different countries? For example, temperature or water usage. Will they influence how much you detect of the RNA or anything like that?
Yeah, there are quite. What I would say is that we are now part of the European testing program with over 50 cities currently collecting these samples. So we're also working with everybody around the world, various organizations, to get to a protocol that is kind of the same for everybody, so that we can then compare the data. And from those, I think we will get a bit more understanding of the variability due to the local conditions. So the temperature obviously plays a role there. I'm not a virologist or epidemiologist, but I think that will definitely play a role in variability of results. And also, although, as I said, we've been doing this for 10 years for various other substances, chemical and transformed kind of substances, this virus is different even from previous SARS viruses, so it would be difficult to give you a definitive answer on that one. Sorry, I cannot be more specific.
No, that's a very, very good answer. Thank you.
Thanks.
Right. Is there any more questions for Dragan? In which case I'll say thank you very much, Dragan. You're more than welcome to hang around, but I know you're very busy today.
Okay, thank you. Thank you for the invitation, everybody.
Thank you, Dragan.
Bye.
So,
our last speaker of the day was Karen Georges, who's the head of consulting in the UK for our utilities. And Karen was talking about the digital collaboration using modern communication tools, i.e. WhatsApp, for international, multinational collaboration between utilities within the COVID-19 pandemic, and how it can be effectively used to share knowledge.
So I'm going to be talking about the WhatsApp group that we set up at the beginning of the COVID crisis and how this has helped water utilities across the globe collaborate and share experiences of coping with the challenges and opportunities that this virus has created. And as Oliver says, perhaps you might think that WhatsApp group is just, a group of friends. What use can it possibly have in terms of uniting people, in a time like this? But you'd be surprised, I'd say. So, okay, so I think it's probably useful for me to just provide a bit of a kind of group on the page type introduction to it. So, like I said, we launched our COVID group at the start of the crisis, which was on the we launched on the 23rd of March, which is when the lockdown started happening in earnest in the UK, really. It's an idea that our chairman had, and we're able to quickly set up a group on WhatsApp and invite our contacts to join. The stats on this page are a little bit out of date, but do show the magnitude of the reach of the group. So we now have around 700 members across over 360 organisations in over 60 countries. So we have people on the groups from Australia to Chile to Peru to Philippines, Russia, Germany, Uganda, South Africa and many, many more. So the aim of the group is really important to understand, and it is for utilities to share their learnings and experiences and to be able to ask questions of each other on how to best handle the outbreak and now how to move into this new normal, or whatever phrase we want to call this next phase. So the key findings from each week were summarised and presented in a webinar on a Thursday, which we held twice a day to allow for the different time zones. So if anyone here is from a utility or regulator, you're very welcome to join the WhatsApp group, and anyone can watch the webinars, join the webinars on the day, or watch them on our website as well. And they are a really good resource for understanding how the kind of crisis evolved over the last few months and also seeing what utilities are doing across the globe. So, I guess there's some really good learnings that we've had from using a WhatsApp group. And I guess the first question might be is why do we pick WhatsApp? So generally or principally it's because it's available in most countries across the world, and several of our water utility contacts already use it as one of their main forms of communication. So we knew that people use WhatsApp and they have access to it. And it allows that quick sharing of messages, news and documents. But we did find it can become chaotic really quickly, with hundreds of messages being posted just to say thank you or acknowledge something that's been sent. So it's important to try and manage this chaos. And we did this through setting some ground rules for the groups, such as, not having to say thank you to everything that's been posted. But also we found it really useful for us to be teasing out those key lessons from the group each week, making sure that where specific questions are asked, we endeavoured to find the answer using our extended network. And also sometimes it was appropriate to use different communication methods, such as email, where WhatsApp wasn't right for sharing a document. We've also recently set up subgroups to manage different interests. So these subgroups include things like the work that Dragan has mentioned in terms of that kind of sewer surveillance work, but also around communications and other topics as well. So I did mention that we do these summary webinars, and they've changed on how we do those over the last few months. So we've started including interviews, for example, and that works really well. In fact, we had Dragan on a couple of weeks ago to talk about the work that KWR are doing on COVID. So I think that the WhatsApp group and the webinars have worked so well because that format allows that fast exchange of information. And this is really important because this crisis evolved so quickly in terms of how people felt about it, the work they were doing, their priorities and so on. And so by allowing this really quick exchange of information, it just kind of gave a huge group of people around the world that open kind of information and sharing across all these different countries. And particularly those countries which might be further ahead in the pandemic, they're able to share their learning, which others could put in place far quicker than they would have done had they had to work it out themselves. So my next slide just gives a bit of an overview of, well, the statistics really and how those groups grew. So you can see the increase in the countries or organisations and individuals over time. So it's weeks at the bottom of those graphs. And the table there presents the evolution of the different groups. So we started with the main group, which is there at the top. And the darker the colour, the more people that were involved in those groups. And then we introduced those subgroups as well, which so currently are around technology. So discussions that might be around the provision of drinking water or wastewater facilities in communities which don't have them already. There's a group around wastewater, where, as I mentioned, that's all around the detection of sewage as an early warning system. WASH subgroup as well, and discussions there also talk about how water utilities can keep providing a service when their income drops, especially important in those water companies which are predominantly domestic and customer-led. And we also have a communications one, which is just really around how stakeholders and the general public can be best engaged with. And that's really just taking off now, and I think that is almost an indication of the priorities of different companies and utilities and regulators as well. Very much now is a time that you can breathe a bit and start talking about communication. And there's a terrible pun at the bottom. It went viral. It did, and we did manage to reach a lot of people. So why did we do this? As cheesy as it kind of sounds, we are driven by the belief that open collaboration and sharing does help to make the world a better place. And people we knew were getting ill. We could see that it was really important that we could utilise our network and expand it as well to allow people to share. So how we did this then, and what did we do? So I mentioned around this WhatsApp group and the weekly summary webinars, but we also have a OneDrive kind of document repository place where we have key documents that are provided and shared around the group. We've done surveys as well, looking for the similarities and differences and understanding what the key challenges are between different utilities and regulators. And we've had case studies from a huge range of different countries. I won't read them all out there, but you can see there's a real broad global number of case studies. And as I mentioned before, we have interviews in each of these webinars. So we've talked to utilities to understand what they're actually doing on the front line. We've had water safety plan talk from a utility in Italy. And then, as I mentioned, Dragan also presented as well. And we have recommended reads, so people's blogs, websites, papers, anything that people want to share that has useful information for the group. And that's all available on the OneDrive system. So this, this just shows the evolution of the different topics that we're really focused on and talked about within the WhatsApp group and in the webinar as well. And you can see at the start of the crisis, not surprisingly, a lot of the talk was around PPE and transmission risk. And then this went more into that management and, coping with the current situation. So looking at water use patterns, detection, contamination, monitoring, and understanding the impact of the virus on business operations. But more recently, you can see that conversations really moved on to how utilities can reduce risks in the future, including understanding implications on revenues, as well as implementing robust water safety plans. And again, that constant talk about how wastewater can be used as this early detection system. So throughout the weeks in the WhatsApp groups, we had lots of infographics shared. And I just wanted to put a couple of these in. These are both from, quite near the start of the crisis or the pandemic. And these kind of show the interest of the group as well, and really about understanding how it's transmitted and where it persists. So, it's not all about words and documents, it's also about infographics. This is one that I really liked, and I think, hopefully a lot of you have seen this one, because it's really easy for all these different groups just to talk about technology or sampling or, quite hard and fast things. But, mental health of your workforce and of ourselves is really, really important. And so this infographic really just shows that evolution of the time and where people kind of might fit within that, fear, learning and growth within this pandemic. And this is another infographic that was shared, and this is really highlighting that we don't really know, I'm no expert, but I don't think we understand exactly where we're going to be in terms of second waves, third waves, fourth waves. How is this going to look? Will the second wave be much higher than the first wave? I think with the flu pandemic at the beginning of last century. So it's important really to, for water utilities and everyone else to be really agile in how they respond to these and to plan sufficiently well so that when whichever of these different scenarios might happen, that people are prepared. So I just wanted to share a few of our key kind of takeaways really. Clearly there are takeaways in terms of using WhatsApp and hosting webinars. And I think in terms of using WhatsApp, it is definitely great for that fast response, but it does need close management to make sure that documents are summarized and people can really maximize the use of those groups. But in terms of the learning from the actual group itself, there are probably 12 key takeaways. So lockdown, timing is paramount. Keeping those asset registers up to date and thinking about supply chains. We had several examples where the planning probably hadn't been as good as it could be, and this had led to several difficulties within utilities. PPE, I mean, there's so much talk about PPE. I think we're probably all quite well aware about it. But social distancing, the evidence shows that trumps PPE to a large degree. Land operations, isolating your shift teams and having one spare. Sounds obvious, but again, there are examples of utilities who didn't do that. Examples of utilities who did, especially those, say, within African nations who are used to, but had experience of other pandemics or epidemics. So it's really important also, in the UK we're relatively fortunate, or we are fortunate, but there are an awful lot of other countries where there just isn't the proper provision of sanitation. And I think it's probably within all of our responsibility to make sure we help those communities as far as we possibly can. Impact of technology, that would be significant, especially around perhaps automation and remote monitoring, for example, especially where teams can't get out and do that sampling themselves. Scenario planning, again, seems incredibly obvious, but if it tells you something important, you should really act on it and not just think that it's unlikely to ever happen, because the COVID-19 shows that anything can happen, I think. A funding crisis is coming, perhaps less so in the UK, but certainly overseas. And those companies, those water utilities which rely solely on domestic customers, for example, or those that rely on industrial as well, the domestic water use has gone up, but only where you have a meter can you then recover that extra cost of that water. And industrial use has massively fallen as well. So if you're relying on industrial companies to buy your water essentially, then you're going to see a massive revenue drop. I've just talked about that water reuse, but there's some also water use. You can see some figures there. So domestic is up by between 5 and 25%, and industrial down by 20 to 50%. Supporting the customer, again, is targeting those most in need and doing the appropriate way of doing that. So rather than blanket provisions, perhaps social tariffs and so on. Politics matter. There's a huge difference in some of the approaches that we've seen with different countries. You can see on the news as well the Swedish approach, for example, to lockdown, where they didn't really do a lockdown, and the influence or the impact that they had, both on their water side of things, but also their infection rate. And that's really important in understanding why different countries take different approaches and how relevant documents shared are, and kind of teasing out those important bits of those documents. And from everything we've seen, and again, I'm no expert, but the transmission risk in wastewater seems to be really low. There have been some newspaper reports which will say the opposite, but generally they've misunderstood what documents, especially around the kind of sewer surveillance type work, shows, hence why communication is so important. But really, if that inactive RNA can be detected in raw sewage within 3 days of infection, so that's probably before anyone has shown symptoms, but as Dragan said, that gives us as a society, that real headroom to understand what that response should be. But there's still, plenty of questions around that and how you transmit or translate that into any kind of policy. So this was a map that came from Dragan, and this does show all the different countries that we're currently looking at that sewage surveillance of COVID-19. So you can see it's a huge array across the world. So what have you learnt so far? I have covered quite a few of these already, but I guess these are I think they're quite useful and important to understand again. So at the macro level, this virus is going to be with us for 2 to 3 years. That's everything that I'm hearing, newspapers are reporting. So we're really likely to have that resurgence and to be able to respond quite quickly as utilities, as regulators, consultancies, whatever profession you're in. Being agile is really important. We're going to have, I guess, these different lockdowns coming in, and again, understanding all the different approaches through this WhatsApp group can be really useful in seeing how people respond to lockdowns, the second, the third, the fourth lockdown as they happen. And I think I've covered those utility level kind of learnings really. But I think technology is probably one that I would focus on a little bit because, as always, it's going to be an important part of the solution. And perhaps something like this will speed up the use of AI or automation or that remote sensing and remote monitoring aspect. So what are the opportunities in a post-COVID world? Well, I think it's good news. If anyone tuned into the Global Water Summit's Corporate Water Leaders panel that have seen this survey, so 63% believe that COVID has raised the profile of the water industry, which I think is really good. If people can understand better what the water industry are doing and their role within wastewater and water treatment as well, I'm hopeful that there's better engagement and better kind of decision making undertaken as well. So what next? Well, we have just launched the Water Action Platform. So this is open to everyone and it's free. There's no hidden secret things or anything like that. It's totally open and free. And the goal of this would be to facilitate collaboration and sharing, and innovation is always an important thing to us. There's always going to be that strong innovation team running through it. So we will continue the WhatsApp groups as they are, but we're going to add new groups as well as other topics come up. So not necessarily related to COVID, but I think having this global network is useful for everyone. So it could be on topics like biosolids or water quality, chemical-free treatment, and so on. We'll keep sorting the chaos from these WhatsApp groups and summarising the real gems of wisdom and the discussions had. And that would be available in the monthly webinars that we're going to hold. And also it will be available on the website, and that will include podcast interviews, case studies. And so if anyone wants to join it, please drop me a line, or there are details on the front slide or the second slide to Megan, who you can just email as well. So this is sponsored by a range of different organisations that share our kind of understanding and belief around collaboration. And these are the current ones here. So we've got consultancies, we've got the World Bank, UNICEF, water companies, and so on. So it's a good range of companies that are sponsoring this. And this slide was just, I'm not going to play the video, but it's a reminder of why we did this. And so we have an interview from Sarah McMath, who's a CEO from Mosul, and she has recovered, thankfully, from COVID-19, and she just talks about her experience. And I think it's really important to bring it back to the people. And, this is a real crisis of humanity, and it impacts different people in different ways. And I think it's always worth remembering that it's about the people, without sounding too cheesy. So what is the new normal? Well, I don't know if I like that phrase, but it's one of the ones that are bandied around. But we don't know when the next wave of COVID might happen, or when even the next pandemic might occur. So for all of us to kind of thrive, we have to be flexible and adaptable. And this is really a cultural issue as much as an infrastructure issue. If we think about working from home as one of the cultural issues, some organisations were really set up for it, others really weren't. And so just having that agile and adaptable mindset can really help people. And there's a nice quote here from these guys at this Italian water utility, and it's be like water, adapt to your surroundings. And then just a couple of things that we found quite amusing. We looked at lots of different companies sent in their data around water usage, And, not to stereotype, but, within Germany, they could clearly show from their data that the morning peak had moved from 7:10 a.m. to 9:40 a.m., whereas the data from the UK water utilities was kind of more showing a roughly 8 a.m. to roughly 11 a.m. And apparently glowing face masks are coming. So I can't imagine being on a tube, for example, with your face mask on, and that will produce this fluorescent signal when someone nearby coughs or sneezes or breathes. Can you imagine everyone just looking at you, wondering why your mask is glowing? So that is my presentation, and if anyone has any questions, I'll be very happy to answer them.
So thank you, Karen. That glowing face mask reminds me of the myth of when you're a child in a pool, and if you took a pee, then there'd be dye going across the swimming pool. But we will see. Any questions from anyone? No one? Is it?
Karen, it's Barry.
Yeah.
It's a terrible echo, but anyway, I'll press on and hope that you can hear me okay. So how much did the group manage itself, Karen, or how much was it that that it was really our utilities that were organising and everything and doing everything? I mean, I just wonder how much resource it was for the company.
Yeah, so it quickly became clear that it wasn't something that could manage itself. So we had someone who was essentially working, it was definitely a couple of days a week, managing the group and pulling out those key learnings. So it is relatively resource heavy.
Right. But you think you can carry on for the foreseeable future doing that?
Yes, so this is one of the reasons why we have sponsorship for the Water Action Platform. That's the new iteration of it, essentially. So with this sponsorship, we'll be able to continue.
Sure. Thank you.
Any more questions, anyone? It looks like there isn't, and I can certainly hear a bit of an echo. So I will thank all of our speakers. I'll thank Mehdi, I'll thank Dragan, who's not here, and thank Karen for their presentations. I think we've had a really interesting set of presentations, and I hope you've enjoyed it. I think it also goes to show what we can do with modern technology and communicating to both water companies and actually with the work Mehdi's doing with the customers as well. So I think if Karen sends me the details of the Water Action Group, I will put that in the minutes for everyone to have a look at. So all that remains to say is thank you, and for those staying on for the CIWEM meeting, I will have it immediately after this. For those of you who are leaving us, thank you very much for coming, and I will send out a doodle poll to everyone for the next date. So thank you very much.
Thank you for watching today's presentations that we're recording on the 24th of June 2020. If you want more information about the Foundation for Water Research and the work that it does, please go to www.fwr.org, where there are plenty of resources for those interested in the water and wastewater industries to watch, including the reviews of current knowledge, which is something that the Foundation for Water Research work incredibly hard on, and newsletters for everyone to follow. Thank you.